So I posted a video basically following a workflow from the 3D Google Earth um, buildings and the 3D Google Earth model using a photogrammetry technique to bring that into Rhino. And so I think at the end, we basically just were kind of looking at this mesh in the Rhino setting. And then Chad posted a couple of days ago saying, okay, now I got to turn this into a 3D print. And that kind of got me thinking what the best way to kind of slice and dice this up in Rhino would be. So I just spent a couple hours working on a script that I think is working relatively efficiently. And I think one of the things here, of course, is that Rhino is not necessarily designed to do this kind of work. Obviously, there are much better modelers that work much more efficiently with meshes and are going to do this in a much cleaner way. I think even reality capture is going to have a better trimming and kind of constraining tool that will allow you just more flexibility in manipulating the mesh than Rhino really gives you. But I think there is some value in pursuing a workflow through Rhino, especially if we're bringing this model into Rhino and we want to do some other modeling on top of it, and then we want to 3D print, this mesh with another building model or massing model inside of it. So I think there are some, while I understand, or I suppose I just want to say I understand that the Rhino is not the optimal program to do this in, that perhaps a workflow is valuable to have, at least to kind of slice and dice this up and make 3D printable files. So really what I wanted to do was be able to go from this mesh, which is a very high density mesh, as you can see, to basically cutting out some of these areas if I wanted to focus on a particular area. And so what I have come up with is, I think, a relatively efficient script. I'll go ahead and change this to white, and I'll show this. So we're basically just going to kind of look at this area. I'll just go ahead and turn this off, and I'll hide this actually. And what I'll do is just walk through this script as we go, I think. So I'm using this curve, and actually before I do that, let me just turn this on. The mechanism that I basically want to be able to use here is to draw a boundary in plan, and then basically have that boundary spit out this kind of block here that has a base to it. And I really wanted that thickness just to be able to work with. So you're basically trimming the sides, and you have the base, and you can bring that into a 3D printing program like Cura, for example, which I'll be using. So this is going to be our block. And for all intents and purposes, let's just use this. I was sort of practicing on this with a more maybe complicated polygon, but rectangles work super well as well. So yeah, I'm just going to hide the mesh here. And so yeah, you can see a little better. This is kind of what we're interested in. This is obviously there's some artifacting here, but won't worry about that too much. So we're basically starting with the mesh, referencing the mesh in Grasshopper, and then the curve that we want to trim the mesh to. And what I'm doing first of all is creating a union box all the way around the mesh here. So if I put the mesh in, it's creating a bounding box. Then I'm basically deconstructing. This is a very simple way of doing this. I'm deconstructing that box into its faces and edges and vertices. I'm finding the area of each of those faces. Then so the area gives you a center point. I'm deconstructing the center point. I basically want to find, I want to reference the lowest face on this bounding box. So I'm deconstructing and sorting deconstructing the points sorting the points from high to low. Then I'm picking the lowest point out of that list. And the way that's working, if you're confused, is when I plug all of the z coordinates of the center points in, it's basically just telling me a list of numbers of the different z coordinates of each of the center points, of each of these center points. So sorting that, identifying the lowest one, and I'm just creating a plane at that point, because I really want to base all this off of a single plane. And the base plane I'm using is just XY. Then what I'm doing is I'm moving that plane. I'm just adding a factor, basically a negative z factor to that plane, so that I can control how deep the base of the base of the 3D printable model is going to be. And then all I'm doing is I'm actually projecting the curve that we drew. And this is sort of why, you know, I think a lot of times some of these things don't actually work super well. It's because when you draw that single boundary curve, is a lot of times it won't be planar. And it just saves you the hassle. It's a little easier to have this built into a Grasshopper script of always just projecting and making sure everything's planar how you want it. So you're not actually, you're sort of relying on you're relying as little as you possibly can on Rhino geometry, which I think in this scenario could be helpful. So I'm projecting that curve down onto the plane that we just created. So then from there, we're basically doing two things. I'm extruding the curve that I just made up, and I'm extruding it kind of an arbitrary amount. Basically, what I want to do is I want it to extend beyond the height of the mesh. So it's just kind of like extending beyond. And I'm meshing it, and I'm meshing it here, and then I'm splitting this mesh, our mesh we generated from the photogrammetry, with the mesh that we just created. So we're sort of just taking a big chunk out of it. And then all I'm doing is I'm actually sorting again by area. And I'm sure there's a better way to do this. But you know, short of just kind of like cycling through the different mesh splits. The thing is there's a bunch of different artifacts that are coming off of this photogrammetry mesh. So all I'm doing is I'm basically sorting this, and I'm selecting. So again, we're sorting, and we're getting a list of we're getting a list of meshes, and we're also getting a list of numbers because we're using area. And you'll see I'm reversing the asynchronous list. And if I reverse this here, just go reverse. So we have one mesh, which is about 7,500, I guess, square feet here, whatever. It doesn't, the units are kind of arbitrary in this case, but that's clearly going to be the like larger, the outside of the mesh, right? Then we are, the second in the list is going to be the one that we're interested in. And then the one that's 122, you'll see in this mesh, the mesh we imported, we actually have this like bottom plane that gets created when you import the mesh into Rhino. So those are the three largest ones. And then you have these like really, really small ones, because I think we're probably splitting a tiny random floating mesh somewhere into two. So I know I don't want the outside one, I want the inside one. We know that the inside one is going to be the one that has the second largest area. So I'm selecting that with just, so you can see the first item in the list, or item number one here. So that's good. Now I have the mesh sort of trimmed and constrained. So the second part of this, and I spent actually quite a while sort of trying to figure out the best way to get the sides of the box that match with the trimmed mesh, because it's a bit of a complicated surface, and I'm sure if you try, you'll probably break the script pretty easily, but it's working the few tests that I did. So I'm going to take the curve that we projected, and I'm going to explode it. And I'm going to extrude it again, actually. So I'm making a second extrusion. It's basically, it's the same. And actually, I could have just reused this mesh, but if you know, there's a little bit of redundancy here. That's okay. I guess actually what I'll do is plug. I could do. Nope, actually, I do want it to be this way. I do want this explosion. And the reason why it's a little bit different is because I want each of these sides to be a unique mesh. I don't want so here we have one extrusion that was the entire bounds that we're using to create, to split this out. In this case, because I exploded the curves, each of these lines of the explosion is going to be a mesh that's extruded. And then what I'm doing is I'm finding the mesh intersection. So I'm intersecting between the mesh we imported, the photogrammetry mesh, which yeah, is actually the full deal, not the trimmed. And I am intersecting with the meshes that we just created. So those are giving me these intersection lines. So each of these now is a line, and you'll see now I have 18 lines that I'm interested in, or that are created from this. What I'm going to do is I'm going to use another sorting command. And the reason for that is I basically want to find, because you can also see I got some kind of rogue lines here, like this line here, which is obviously chopping through a tree somewhere. We can see here. Oh, it's on the other mesh. I see. Yeah, that's why. Let's go. It's here. Yeah, you can see that it's chopping through this tree, and we did not bring this mesh along, this little mesh along here, right? Because we chose only this mesh inside. So that must have been one of these meshes, right? So I'm intersecting, sorting by length, and then I'm basically doing the same thing that I was doing before. I'm selecting those curves, and then those curves are giving me this this line here, or these lines here. So then what I'm doing, and you can see that each of these lines is occurring at a trim mark. So like we can go over here. So sorry, this is a little bit complicated, but you can see that this line here is getting cut here, and it's getting trimmed up at the corner here. So these are all in line. Basically, what we want to do from this point is I'm actually projecting these lines back down. And the reason that I'm doing this is I'm projecting them back down to that plane that we initially generated. The reason why I'm doing this, not just using the lines that we used initially, is because it's basically list management. I could probably take these lines, or rather these lines that I shattered, and plug them back in, and maybe I'll try that afterwards. But I think the best way to do it actually is, or the most straightforward way, and sort of in terms of the list management for me, is just to project back down. And so right now I have the curves up top, I have the curves down low. So these two curves are basically matching, right? This curve is matching this curve is matching this curve, this curve is matching this curve. And then, oh, and I should also say, I am making sure not to flatten any of these inputs. And the reason for that is, again, a list management question. And I'll show you why. So here, I want to, and I'll reverse this too. I basically am more interested in each of these mesh intersections are considered a separate, they're separated in the data structure, right? They're a separate branch. Branch in the tree of data, right? So you can see here, I have a bunch of these lines separated in branches, and I'm interested in the length. And then when I sort them, put it here, I have the longest item up at the top of the list in the branch. So, okay, hopefully that all makes sense. So basically, I just want all of these things to be matched up. So then I'm taking this, the curves that we just projected, so the 7 curves that we projected from the 7 curves that are intersected with the mesh. And what I'm doing is I'm basically selecting the first item in that list. And actually, I don't even need to do that, but I did need to do it here, I think. Oh, maybe not. Oh, I know this is a leftover remnant from something I was doing before. So I actually don't need these list items, I believe. It's asking me for it. Why is it asking me for it? Maybe some of these. Well, regardless, I don't know what exactly my problem is here. Anyway, doesn't matter. List item here. So we have our 7 curves. Then I'm finding the endpoints of each of those, and then I'm making a set of lines that are at the each end of those curves. So I've got these 2 lines, and then I'm making these lines here at each end. Hope that makes sense. Right. And then I'm merging all of these curves together, right? And then all I'm doing is I'm creating a boundary surface around all of these boxes. So now I have this boundary surface that's kind of framing the edges of the mesh. If I select that here, you can see it's framing the edge of the mesh quite well. And I have the boundary surface actually at the bottom. So this is just the B-rep that's actually just being taken all the way back from this projected curve. So I've got boundary surface, mesh. Then I'm meshing all of these together, and I like to just kind of keep these separated. So just for in the future, I can sort of pick and choose which one I want. I'm mesh flattening and I'm mesh joining, and then now you can see I have the single joined mesh, and I believe it's still an open mesh. Let me check. Let's see, open. Open, what is it? What is that command? This is so funny. I feel like I was just using it. Open, mesh, closed. Is mesh closed? Okay. All right, is mesh closed? False. Okay, so open mesh, but I think for now that's okay. We have the for our purposes, I think this is going to work just fine. It's probably open because the mesh, there's probably some holes in the photogrammetry mesh, but no matter. So now we have this block pretty well defined. All I'm going to do is bake this, and you just bake it on whichever layer you want. Just bake it on layer 1. And I don't need to group it, just no group. Okay, so I think now we're done in Grasshopper. So now I'm going to take this block and select it. You can see now it's come through as a decent mesh. It's okay. Probably could do with a little bit of smoothing. I think you could remesh this if you really wanted. It takes a little longer, and that could be a smart thing to do if you wanted this to be a little bit be a little nicer. But for now, I'm just going to export selected. I'm going to save it in my 3D print folder as not Waterloo Station. And just press yes. Okay, I'm going to save this as a binary. So now going to Cura. I'm using an Ender 3. Open this up. Import your not Waterloo model. You can see it came in kind of small. Obviously, if you were doing this properly, you would want to scale things in a more sensible way. But I'm just gonna do it by hand because I'm lazy. And probably just, well, actually I don't need to rotate it. But what I am gonna do is, because I did this a little bit on purpose, I left a pretty thick base. And the reason that I like to do this is just so that I can actually move this down a little bit and manipulate this in Cura. It's just easy. I probably don't need to show you print settings. I'm just going to do standard quality. I'm going to just turn the print speed up to 60. And I don't think we need, yeah, just do a skirt. And I'll do a grid. Actually, I'll do, yeah, I'll just do a grid. Doesn't need to be very, very interesting. Supports, no support. Yeah, I'm gonna leave supports off in this. Okay, I think that's good. So let's slice it. Shouldn't take too long. You can see, I'll show you in a second. You can see some places where Cura is a little unhappy, but I will, like you can see it here just a little bit. Okay, 7 hours, pretty good. So you can see here, it doesn't know what to do. It's a little bit unhappy, but it kind of deals with it in a pretty reasonable way. So let's preview this. And it's gonna do something funky, like it's gonna try and print in midair, which obviously is not ideal. But like this print was never gonna be particularly amazing. And if you really, you could easily, trim that out or delete that in Rhino if you really wanted to. So this is the toolpath. It's obviously this is obviously a very intricate model printed at a pretty small scale. So there's obviously some problems with it. But I think we'll get the picture. We'll get the kind of get the main idea. So let's save this. I'll save it to my drive, and then we can watch a time lapse of it printing.